every yeast is very different and produces different flavors. So we wanted to get the flavors of our region.
Considering that we started with 7 million.
Yeah, but still, we're gonna harvest yeast, and we have been for 3 years from all around the county and around the region, and then produce beer with actual the bacteria and local yeast. To make it sound a lot simpler than it really is, you harvest yeast in the field, so then we bring it to the lab and we plate it. So we put it in petri dishes of different types. You plate it, you pull a colony, you grow it up, you plate it, you pull a colony, you grow it up, you plate it, you pull a colony, you grow it up until you have a single cell. So we went from hundreds or even thousands maybe of organisms per milliliter of work from a spontaneous fermentation to one single organism.
This is a picture of the yeast that's put into a hemocytometer that it was designed to count blood cells in hospitals. It's kind of a funky looking device here with grids on a couple of surfaces. And what you're seeing is the grid in the background there, and the little dots on there are yeast cells. You'll get 30, 40 or more different colonies growing on a medium like this. And as you isolate them, you've got to isolate each one independently and start to grow it up and see what you got, because some of them might just be garbage that don't do anything or make crappy beer or don't make beer at all or terrible off flavors. So each one has to be treated individually and grown up and tested and re-isolated so that you can figure out whether you got good, not so good, the best yeast that anyone's ever found so far. You never know. So that's why you have to isolate each one independently. We've got 1,000 times more cells per milliliter than what we started with.
Yep.
Which means, in theory, you could take this batch and do 20, 30 more.
Yeah.
Easy.
Yeah.
Out of that.
And you need people who understand both the chemistry side and the biological side of the whole process, basically. You need to be able to measure which chemical interactions occur and which biological activity should be occurring and what the cells look like at each stage of the process. So it's a pretty intense process to do self-harvest, isolation, propagation, isolation again, propagation again, until you reach a point where there's something to test as far as does it make good beer. Then after it makes good beer, then propagate enough to make a batch of beer. It's a very long, intense process, but it's well worth it after you do it.
I've been doing columns electronically on a single one.